one and all present over here. I, Shruti Patel, Parul Institute of Assistant Professor from Parul Institute of Pharmacy, hereby welcome you at webinar platform of Parul University. It's great pleasure for me to introduce our today's speaker Deepak Mishra, who is going to talk with us about fundamental on lyophilization process with PAT tools. He is principal scientist in a formulation of complex injectable at Biocon, Bangalore, Karnataka. He has experience in a formulation development as Precious Kabi Oncology Limited, worked at Zydus Cadila Healthcare Limited and Biocon Pharma Limited. He has the skills on lyophilization, QBD, FMEA, pre-filled syringe device, glass delamination, 505(b)(2), design history file, etc. Here we would like to request Sir to share the knowledge on lyophilization process with PAT tool. Over to you, Sir.
Yeah, hi everyone. First of all, I thankful to Asha ma'am to provide me opportunity to present to you all of you to this presentation. And actually, I'm also working PhD under the guidance of Dr. Asha ma'am. And here I'm presenting lyophilization fundamental basics as per my industrial experience and my whole 8 year of experience. Hello. Ma'am, I'm audible right now?
Yes, sir, you are audible.
Yeah, yeah, okay. So I'm discussing about lyophilization. First of all, you already Shruti explained me in very well manner. So right now I'm presenting lyophilization basic concept and use in the industrial point of view and for also useful for your college academic point of view. So first of all, we are starting with lyophilization. Lyophilization is more science. Somebody say it is the art, and somebody says science. So it is more science than art. So it is the combination of the art and science. So lyophilization, first of all, we are understanding as you know. I think you all are aware for the lyophilization. What is the lyophilization? I think everybody is know what is the lyophilization. So I am explain again. Lyophilization or freeze drying is a process in which water is removed from a product after it is a frozen and placed under vacuum. So in the vacuum, it is very important in the lyophilization process and allowing the ice to change directly from solid to vapor without passing through a liquid phase. So it is directly converted into the solid is directly converted into the liquid is directly converted into solid. So this is the process. What is the lyophilization? So the lyophilization is a three-step process. First of all, one of is freezing. Second one is primary drying, and third one is secondary drying. So we are discussing in next few slides all the process and tools also. So what is the useful lyophilization in the formulation development and any formulation? So it is the enhance the stability of dry powder. So if your molecule is not stable in the liquid form, so we can use as a powder in the use by the lyophilization process. There are also other processes also available, but just like sensitive molecule, we can't use frying in the other manner. So we can use lyophilization to enhance the stability of dry powder. Second one is removal of water without excessive heating of the product. So if our product is heat sensitive, so we also use this process for removal of the water in the our drug product or API or drug substance. So this is also useful in the lyophilization process. And rapid and easy dissolution of reconstituted product. So So after lyophilization, reconstitution and dissolution is easy for the product point of view. So this is the lyophilization brief, and also slide lyophilization process. So we already discussed, and everybody I think know this is the 3-step process lyophilization. So first one is freezing. So in this step, if our bulk product, so we can use in the vial. So in the first step, freezing in solidification state. So in this step, we can use minus 40 to minus 60 degree for the freezing. So in the freezing, our molecule is stable compared to liquid form. So that's why we have starting with freezing in the solidification, then primary drying. So after complete freezing, we can use vacuum and temperature increase. And after we are discussing how to select the primary drying temperature, we will discuss in the next slides. So primary drying is first step of the drying process. So in this step is ice sublimation. So sublimation is the process of removal of water in the sustained increase of temperature. So in this step, 5 to 10% water remaining in the our bulk formulation. And the third one is secondary drying. Secondary drying is desorption. It is after 5 ice sublimation, some bound water also present in the formulation in the lyophilized form. So after desorption, it will completely remove the water. So there is the 3 step of the lyophilization process. 1 or 2% water remaining, so less than 3% is sufficient in any product, in any lyophilized formulation. So we can, this is the process of shelf temperature and time point of view. So process. Second, evaluation. So this we will also discuss in the next few slides this lyophilization process. So next one is evolution of lyophilization. So lyophilization is the primitive lyophilization and advanced lyophilization. Primitively, we can use trial and error approach, more batch rejection, because we have so much trials, and longer cycle duration, higher cost of production, because lyophilization is a very costly production point of view, very excessive, and production point of view is very costly. So evolution of lyophilization is primitively we have used trial and error approach, more batch rejection, and longer cycle duration. So our cost also increase, our timeline also in academic point of view also timeline is increased. If you are doing PhD work or M.Pharm work, so it will increase your work impact on your work also. That's why right now it's available some advanced lyophilization process also. On the basis of advanced lyophilization, it's based on scientific approach, less batch rejection, shorter cycle, and cost-effective production. So we can use academic and industrial point of view. We can see what is the effectiveness of our product, and our timeline also shorter, and rejection industrial point of view, we can reduce the less batch rejection. So this is the difference between primitive and advanced. We can discuss what is the advanced lyophilization in the next few slides. So how to select the cycle development in the lyophilization process? How to select means how to select the temperature, which temperature is suitable for any product. Means if I'm using any peptide, so which temperature I'm going for the freezing, which temperature we take for primary drying, and which temperature we are going with the secondary drying. It all are dependent on the critical temperature. Critical temperature are determined in the 3 or 4 techniques. I think in the academic point of view, you can only use DSC, but in plant, means in R&D, we can use FDM, impedance analysis, DTA. DSC is differential scanning calorimetry, everybody know. Freeze drying microscopy is FDM, impedance, and DTA analysis. So I think everyone is aware for these techniques. I think FDM is not aware, you all are, but the impedance, DTA, and DSC, I think everybody knows. So this is the sophisticated and sensitive technique available to accurately determine molecular mobility within the frozen stage, because in the freezing stage we require some critical temperature. We are going with next step like sublimation, because if we take any temperature and we going directly in the primary drying, so product will collapse. Collapse means it will hurt cake like. So after reconstitution, it's not possible to reconstitution. It is not helpful for the patient safety also. So frozen sample, thermal event, and drying behavior of liquid product. So DSC, FDM, and impedance GD analysis we are discussing in next slides. What is the DSC? DSC, I think everybody know. So on the basis of DSC, we have select the critical temperature. Like is glass transition temperature. So glass transition temperature we can determine by the DSC technique. So you can show here minus 26.65. It is a beginning of criticality of the molecule. So in this temperature, minus 25.94, it will product will after increasing the temperature, means minus 25 to we can go minus 24, minus 23. So product will collapse. So we have select the minus 25.94 for the primary drying starting. So this is the temperature for primary drying selection. Initial critical temperature for the primary drying. This is the zoom area of the, this is the modulated DSC. So in this you can see in minus 25 you see one event you can see here. So after minus 26 to going minus 25, one event will show. So this is the process. We have select the temperature of the primary drying selection. So minus 25 our primary drying will be start with on the temperature of minus 25. So this is the selection of the temperature in the primary drying. How to select? This is the process with DSC. So one more technique we have used in the plant, our R&D. This is the FDM. This is the freeze drying microscopy. It's a similar to our lab microscope, but in this microscope we can also use temperature depression, freezing, primary drying and secondary drying. Also use the vacuum. So vacuum applied in this technique. So this is the difference between the DSC and FDM. So in FDM, you can see first image. It's a I take 2 microliter sample of drug product like peptide molecule in the water formulation, dried with good structure and minus 32 degrees centigrade. So this is the beginning of FDM. So this is my molecule. Left side is a blank screen and the right side is my product. So you can see first minus 32 degrees, it is safe. After we have increased the temperature and going minus 25 degree, so beginning the collapse. It is, you can see in middle line. So this is the beginning line. The first sign of collapse, onset observed as the temperature at the temperature reach minus 25.4. So in this technique, we can also check our product molecule. Our molecule is collapse on the minus 24 or minus 25.4, above to minus 25.4. So you can see collapse also increase in the third slide, third process. The loss of drying structure become more apparent as the temperature reach minus 22 degree. So if we go minus 25 to minus 22, so you can see here difference in the collapse is area is increased. And after last slide, you can see last image, you can see as the temperature reach minus 18.9, the total collapse of drying structure was observed. So we can see here in the middle line, the collapse is total collapse structure. So this actually I can't show here video because I have also the video of this FDM process. So you can understand what is the step. We will go first starting to end. We can all process understand on the process of freeze drying microscopy. So this process will helpful for the lyophilization cycle development. So these both technique we can use in R&D, and DSC we can use in the academic point of view. So next is the process. So on the basis of DSC and FDM, we can select the temperature. You can see first, because we know the freezing is basically is minus 40 to minus 60 degree. So in this step, we can use stopper, half stopper. Means their lyophilized while stoppers are different to normal stoppers. So in this stoppers, we can there are two highlight means two bulk process like. So In this stopping, first we start with primary freezing step. So you can see formation of ice crystal is started. So in this step, starting with freezing, so formation of ice crystal is started, and then we can select the how much time will is used in the complete freezing. So after formation of ice crystal and after freezing, you can see in the above line minus 40 degree. The straight line is shelf temperature, and our product temperature is below the red color in below the shelf temperature. So whenever our product temperature will cross the shelf temperature, it will called primary drying endpoint. So on the basis of primary drying endpoint, we can see if in my product only 5 to 10% water is remaining. And next step we going secondary drying. So secondary drying we can, because bound water we can also remove. So we can increase the temperature of secondary drying step. In this step, desorption of unfrozen water, and in primary drying, sublimation of ice crystal, and void formation also in the in the primary drying step. So it will remove by the primary drying with the help of vacuum. So after that, desorption of unfrozen water, our molecule, our drug product have only less than 2% or less than 3% water in that time. On in the 2% and 3%, it's a good water content in our molecule, because on the this 2-3% will not impact on the stability, because on the basis of different product to product different, this is the process. And after that is stopper inside the lyo while completely stopper and then seal. So this is the whole process in the inside the lyophilizer. Now first of all, I want to also see one video so you can understand what is how to process.
Dedicated lyophilization facility. Freezing the product. Converting solution in the form of ice. Primary drying. Sublimation of ice directly into water vapors. Secondary drying. Eliminating the final traces of water. Stoppering and capping the lyophilized product.
So this is the whole process of lyophilization. Video will show everyone now. Viewers, hello. I'm audible right now.
Yes, sir.
Yeah. Okay. So we can go next step. Our pad tools. We can use the pad tools in the lyophilization process. So this is the pad tools for lyophilization. Pad tools is the process analytical technology we also use in the solid the oral dosage form. There are lots of pad tools, and in the parentals we can use in the lyophilization process. Process analytical technology is a system for designing, analyzing, and controlling manufacturing through timely measurement during processing of critical quality and performance attribute of raw and in-process material, and process with the goal of ensuring final product quality. So there are lots of pad tools we are using in the lyophilization process. So we can discuss here in one by one. The first one is thermocouple. The thermocouple is the in the just like a probe in the vial. So in this probe, we use directly contact with the drug product, and on the basis of this probe, you can show here, you can see here the shelf temperature and product temperature. The product temperature we can check on the basis of this thermocouple, folks. So on the basis of this thermocouple, we can design our development, we can design our life cycle on the basis of this thermocouple. So this is a very important PET tools. Commonly we are using this PET tools in our development. Next step is primary. Next PET tool is PRT test, is barometric pressurized test. So you can see there are two chamber. I think you know, aware of this concept of lyophilization. So in this, there are two chamber in the lyophilizer. First one is condenser part, and second one is shelf part. So in the you can see in the first left hand side, they are divided in two parts. So in this time, isolation valve is open position, and always vapor flow in the condenser. So in the condenser, vapors going in the condenser, and condenser mimic the process. How much water is, how much pressure is inside the chamber. On the basis of pressure and water moisture content relation, they will analyze how much pressure is remaining. On the basis of it will increase or decrease the cycle time and duration. And another right hand side in image, you can see isolation valve is closed position. So it will close after 30 every 30 seconds, and measurement of the life cycle. And on the basis of this measurement, we can understand how to cycle is developed. So this is the very important pressurized test parameters in the R&D. We can use this because can be used during primary and secondary drying. Primary drying, we can also select pressurized on the basis of pressurized test, temperature selection, endpoint detection, and may create slight disruption during lyophilization cycle due to closing and opening of the isolation valve. So this is the drawback of this pressurized test. One more thing, we cannot discuss PET tools positive and negative points. Positive thermocouple is positive point is real-time product temperature monitoring. So we can see what happening our product in the lyophilizer. So on the basis of thermocouple, we can understand this process, and not the representative of all inter batch. This is because it will use only for the we can see only temperature of our drug product. Barometric pressurized test. In this, can be used during primary and secondary drying, but may create slight disruption during isolation cycle due to closing and opening of isolation valve. So on the basis of this opening and closing of the isolation valve, it will be very disruptive of our life cycle. So the life cycle also will not impact or properly impact on the process. So it will harmful for the process also, lyophilizer also. So this is the drawback of this PET tool. This is the Pirani and capacitance manometer. There are lots of pressure gauge in the lyophilizer. Basically, is the Pirani and capacitance very important pressure gauge. So on the basis of this, Pirani and capacitance only come in high advanced lyophilizer only, just like smart lyophilizer in or SP Scientific. So this lyophilizer you can use in the this PET tool we can use in only that lyophilizer. So one of the accurate method of detecting primary drying and point. So in this you can see Pirani gauge and capacitance manometer. So Pirani gauge temperature and capacitance manometer pressure. So at the one point is endpoint is called primary drying endpoint. So we can select the endpoint selection of the primary drying on the basis of Pirani and capacitance manometer. So but it is not compatible with sterilization, means sterilization, steam in place, and SIP method. So not present in all plant scale lyophilizer. Next is TEDLAS. I think everybody knows TEDLAS, tunable diode laser reflection spectroscopy. On the basis of TEDLAS, we can see high accurate during primary drying, fast response time with continuous monitoring. So in this process, we can understand TEDLAS we use for the moisture detection in the secondary drying. So there are lots of lyophilizer. It will inbuilt already in that lyophilizer. But right now is basic models. It will we can use additionally TEDLAS inside the lyophilizer. Second, the drawback of accuracy is compromised during secondary drying, and this is not able to detect the solvent. So only useful only for water detection. So that's the drawback. And one more is the latest technology is for PET tool is LioPlus. My LioPlus is simply its mechanism is just like my mass spectral photometer. So in this, able to detect moisture content, silicon oil leak inside the chamber directly, and the measure moisture drop inside chamber very accurately and correlates the measurement with the actual average product moisture inside the vial. Or detection of co-solvent. So we in TEDLAS we can't use the co-solvent, but in this technology we can use the detection of co-solvent. So we can, on the basis of cycle development, we can use this PET tools, and our cycle is very innovative and a very short duration cycle. And from industrial point of view, it is very cost effective. So that's why we are using its LioPlus in our cycle development, our lyophilization process. But the drawback is newer technology, not much explored. So the limitation of the lyophilization cycle, this is very less company are using this technology. This is the PET tools. Basically, there are 4 or 5 major PET tools are in the lyophilization process. One more important PET tools is Smart Lyo and AutoMTM. So Smart Lyo is the process we can reduce our lab work on the basis of Smart Lyo cycle. So first of all, we know our drug product collapse temperature, means we can determine by the DSFDM, and we also know the glass condition temperature. If I'm using any vial, so I know the thickness of the vial and drug concentration of the vial, drug concentration of the solution. This is the basic parameter. If we know, so we can develop the automatically one cycle, almost final cycle. So we cannot take 15 to 20 trials for the LIGO cycle development. Initially, we have, if we know the data of basic means your physicochemical parameter like formulation and our vials, and so we can develop the cycle on the basis of 1 or 2 trials. So this is the process of Smart Lyo. Smart Lyo is coming in right now in the SP Scientific Lyophilizer is LyoStar 3. So in this cycle development based on the manometric temperature monitoring, it is MTM, is a pressure gauge, a representation of batch size. So we also know the how much batch size and we are loading in the lyophilizer. So on the basis of these parameters, it will generate automatic cycle in the Smart Lyo process. And also AutoMTM is the cycle. If you develop any cycle, so you can check your cycle is agreement, your vial size, your drug product material is good or not. So we can check this Smart Lyo and AutoMTM mode very effectively our product development, and very useful. This is the industry point of view, and lab academic point of view, very helpful to development the cycle. So next one is drawback. Drawback is very minimal, like not suitable product with concentration less than 10 mg per ml, but sometime it will work on that product also. Not suitable in solving problem with the product blowout or ablation, means sometimes the product is in the lyophilizer product, the drug product vials, means drug product vials are break, and sometimes is fly out the material in the vials. So this problem we will recover on the basis of some trials we can use after life cycle development. After Smart Lyo cycle development, we can reduce this. So these PET tools are using in characterization cycle development. So I have one, before ending my presentation, I have one also case study of my development. So I am working on peptide product development. I can't share you the name of the product. So peptide product. So I find out the problem. Hazy reconstitution solution means you can see before intervening in the patient, it will be clear. So my product after reconstitution, it will hazy. So hazy reconstituted solution and presence of visible and subvisible particulate matter. So it is very means you can see in parental point of view, it is very big crime if your product in if you have product in particles or hazy. This I'm develop the cycle on the basis of conventional cycle development. So we have taken the many trials after development of the cycle. I find out the reconstruction. But if you want to discuss me, so I will share you the number and mail ID. So you can discuss me with the additionally. Hello, I'm audible.
Yes, sir, you are audible.
Yeah, yeah. Okay, okay. So, so on the basis of smart live technology, there are four agreements. Basically, there are four agreements are present in the drug product. So, first one is good agreement. This is the ideal, but not possible to any product. Second one is amorphous skin. Amorphous skin is just like a skin in the drug product. Like if your drug product is uh, actually I don't have picture right now. So amorphous skin is after above the drug product, it will show one screen layer, means just like you can see any tablet skin just like similar. So amorphous skin are showing. So this type of agreement, if you are in the product have amorphous skin, so this type of graph will show on the basis of dry layer thickness and product resistance. And second one is formation of cracks. If you can, I think you can, if you have seen in previously if any live price product, you can see cracks in the drug product. So smart live technology find out the how to determine how to become this cracks. So product resistance and dry layer between the we have checked on the basis of dry layer thickness and product resistance. So cracks generation of the live cake also find out this smart live technology. And third one is micro collapse. So micro collapse in my product is in micro collapse is find out because micro collapse is not shown in the drug product vial. After reconstitution, it will find out how many particles is showing in your drug product solution after reconstitution. So it will impact of the patient also because patient safety is not patient compliance is not possible because of the subvisible particle or visible particle. So on the basis of this smart live technology, I was use my product and conventional cycles because of the conventional cycle development failed to solve this problem. So I used this technology, smart mode live technology, and I found out the problem is micro collapse. After find out my problem is micro collapse, so I have select the primary drying parameter. I have changed the cycle, and on the basis of changes, my cycle is fully developed, and my problem is resolved, and reconstitution so hazy solution will become clear. So this is the case study of my previous product. So if you have any questions, so you can ask me. Thank you so much. If you have any question, you can not asking, so you can mail me or you can WhatsApp me on my number. So I will answer every question. If you ask any literature, if you want the literature on the basic cycle development, life cycle development, protein peptide delivery development, I will share.
Sir, there is one question from the audience.
Yeah,
Yes, Deepak sir.
yeah, please.
Yes. So there is one question from audience. Which kind of the products are not suitable for the lyophilization?
Which type of product? Actually, I think if your requirement is product stability, if your product stability, you required your product is not stable in the liquid state, so you can lyophilize that product. But most of the product are coming in the tablet form also. So you can cite me ki, this process is we can also prepare the tablet because the tablet is going first pass metabolism, ADME, everything. So it will directly impact your body also. So you can reduce the side effect of clinical point of view. So we can reduce the side, or if you want to directly you want to give the solution in the IV or SC or IM. So that molecule we can use in the lyophilization process. So because that product are stable in the solution form we required, because we can't give the solid or powder form that time, so we can use the lyophilization process, that type of technology. Yeah.
Second question, sir. Any idea about onco injection done through the lyophilization process, which can add some, share some point?
Actually, repeat your question. Yes, Shruti, repeat your question, please.
Yes. Any idea about onco injection done through lyophilization process?
Onco injection.
Yes, sir.
First of all, we understand what type of molecule you have prepared. Means which type of product is. If in this onco product, there are most of onco product also available in the liquid form also. But in liquid form, it is very because most of the onco product is not soluble in the water. So we will use non-aqueous solvent of that time. So if you want to not going non-aqueous solvent, not going aqueous still because of the not solubility in the water. So that time you can lyophilization process is suitable. So most of the lyophilized product, most of the oncology products are coming are in the market in the lyo form also. So if you have any product just like paclitaxel in the lyophilization formulation also in available, and cyclophosphamide, and most of the live product available in the onco product are available in the live form also.
Okay, sir. One more question. How we can fix the number of cycle required for the lyophilization for a particular formulation?
So this is very good question. Life cycle development is very main step in the development of the formulation of any formulation development, because lyophilization process. So first of all, you select the cryoprotectant of the solvent or the solution. So after selection of your cryoprotectant, you can use you can because I think advanced lyophilizer is not in the academic in colleges. So you can take you can initially you can determine the DSC, the critical temperature of your product. So on the basis of critical temperature you can understand what is the temperature of your collapse or and your process. It means primary dyeing and secondary dyeing. So on the basis of your prerequisite, means like critical temperature, formulation parameter, you can understand, and on the basis of that trial you can determine the just like 4 to 5 trial you can develop your finalize your cycle. But it's very critical, so optimize. So that's why we are using advanced technology, because most of the just before advanced technology 10 to 20 trials, 50 trials, 60 trials on the basis of product molecule. Means molecule behavior also impact on the lyophilization process, because not stable sometimes, not stable with cryoprotectant. That's why we have taken so much trial in the normally primitive technology. But advanced technology we can reduce the cycle, or I think in my previous product I have developed on the 4 trials only. So this is depend on the lyophilizer, not on not your process or your formulation. Your if your advanced technology, so you can prepare very fast your development.
Sir, protein nanoparticle can be done using lyophilization process?
Yeah, I'm already doing my protein nanoparticle. Protein nanoparticle because protein is very sensitive. in the lyophilization process. So you have select to a specific cryoprotectant for the lyophilization process, because denaturation of the protein is very happen in the life process. So first of all, you select the one stable cryoprotectant. Then you have decided the cycle on the basis of your critical temperature determination. Then you select the process. Then you, after that, you select the technology of life cycle. So these all are impact on the protein nanoparticles. So I'm already prepared the protein nanoparticle life cycle by the life cycle process, because because of the nanoparticle are not stable in the liquid form, or your, if you are preparing in the academic, so you see your product will your nanoparticle will degrade, or um, your means it will not stable. So on the, for a stability point of view, you can lyophilize your nanoparticles, so it will increase the shelf life. Just like if your product is stable only 6 months, so it will increase to 2 years by the lyophilization process. So it will very helpful for the nanoparticle microsphere. So in the market already available the nanoparticles, protein nanoparticle also available, microsphere also available, liposome also available. So on the basis of lyophilization process, we can prepare the safe technology for the our stability of point of view, or of our complex molecule, complex formulation.
Sir, one more question. Can we do lyophilization of DNA and RNA based product?
DNA and RNA based, because for the DNA we can't use the most of the cryoprotected we can't use because of the DNA we have inbuilt stability issues. Actually, I have not worked on the DNA and RNA, but it's already in the market DNA and RNA based lyophilized product also available. So if you want, so I will share you some articles. So I will share you, send you my message me on WhatsApp or mail me. So I will share you the article. But already DNA based, RNA based vaccines also available, and drug products also available in the market.
Thank you very much for such a technical information on a live with process analytical technology. I would like to extend sincere thanks to, on behalf of Parun Institute of Pharmacy, Faculty of Pharmacy, University. Thank you, sir.
Yeah, thank you so much. I was used our knowledge I share here, so I'm very happy to share you every our knowledge and our experience. So if you have any query, if you have any doubt after my presentation, if anyone not asking here, so you can WhatsApp me on my number and mail me on my mail ID. So thank you so much. Thank you so much, ma'am, Shruti ma'am, and everyone. Thank you. Thank you so much. If you
Thank
have
you.
any other questions, so I will answer it right now.
Thank you everyone for being a part of this webinar.